All right, welcome back. This time we're going to be talking about prompt engineering with Vertex AI, and I misspoke. This one's also going to be with Naresh, a principal technologist from Google. And I'll let you take it away, Naresh.
Thank you, Katie. So, hello everyone. Naresh Jasatani again, and I hope you're able to see my screen. Now, in this session, what we're going to do is I'm going to do a quick recap of what we did in the last one, and then talk about the prompt engineering. Many of your questions that you had may be answered in this session. Now, let's let's hear a story. Imagine that you are in a library with hundreds and thousands of books, and you want to ask a question saying that you want to know about Abraham Lincoln, know something about Abraham Lincoln. The way librarian is going to trace that book, the autobiography of or biography of Abraham Lincoln, is by going to history or historical, nonfiction, biographies, and then he or she is going to look for Abraham Lincoln's book and they're going to bring it to you. So the way to traverse to that information that you need is known as prompting. Prompting defines how you ask a model to go fetch information that you need. So, oops. Okay. So prompting means how you ask a question and how you trigger a prompt to answer. Now, in the previous session, this is what we understood. The way you access Gen AI APIs on Google Cloud, not on Bard, but an enterprise version on Google Cloud, is through Vertex AI APIs. Using Vertex AI, you have Model Garden that you look at the list of models. You have Generative AI Studio, which provides you an interface to build your prompts. And then you have tuning, or you have models that can be tuned for your specific data. Let's take a use case. You are building a Gen AI application wherein you want to categorize the question, the service request or the customer request that come to you. Another example is you wanna you have a use case where you are recommending a customer based on his or her preferences, a product or set of products. So two use cases we are going to see. Number one, you have customer tickets, customer problems, customers issues that you want to categorize, and the second one is how do you recommend a product or multiple products to a customer. The way you do it, the first one, or you want to train that model, is through prompt. There are different ways you can train a prompt. Zero shot, meaning no examples. A shot means an example. So to this model, you say just go and train. That means zero shot. You are going to say classify these tickets. That's it. That is zero shot. The large language model, because it doesn't know your classification items, it's going to do its best to classify. That is zero shot. A zero shot is an example where you do not provide any, or is a prompt where you do not provide any example to the model. One shot means you provide one example, and I'm going to explain that in a few seconds, one single example to the model so that the model has a context or an example to look at. Few shots, because your classification is a little challenging, you provide multiple examples to this model so that it understands how do you want to classify. Now, let's see a quick demo on it. And then we're going to go back and I'm just bringing it up. So pardon me here. Wonderful. So there is an example, classify help tickets. Look at how you set up. This is an example of few shots. That means you're providing few examples. When you are providing few examples, this interface provides a free form, meaning you just want to write as you wish. And structured, it's more structured in terms of context, examples, input, output. In the context, you say that you want to define three categories: credit card, banking account services, loans, and mortgages. This is for a different business use case, but you understand where I'm going with it. And you provide few examples saying that if something of this effect, it's a credit card. And you don't have to provide all the examples out there. You provide some indicative examples and look for those borderline cases where the training fails. You add them and retrain the model. It's not about retraining, it's prompt tuning a model. And finally, you want to find this. Now, there are few hyperparameters which we have not talked about yet. Temperature means the degree of randomness. That means how wild or how diverse you want this model to think. Zero is least diverse or very deterministic, and highest probability is one. So if you want to keep it zero, it's not going to think big. It's going to just confine itself, deterministic, confine itself to what you have provided the samples on. What we have observed is a zero point 0.1 or a zero point 0.2 on temperature works better, sometimes 0.3. Token limit. Token limit defines what is the size of the token that you're expecting the output. Because the output is just one single word or set of categories, you can set it up to 256 or even more. Because it's classification example, you are limiting the number of classes. Top K and top P are different hyperparameters. They wherein you could select one or the other. At this point in time, I'm going to leave it as is. I'm not going to make it more complicated for you than it needs to be. And I say submit. And based on this, it's able to categorize only the categories that you mentioned. Bank account services. So this is one of the methods that you provide examples to the prompt, and the prompt does the job for you. Now, let's go back to our conversation here. This is what is known as prompt engineering. You define prompts, you suggest examples to the model, and the model does its job. The other method is the tuning. Let's look at the second example. In the second example, wherein you wanted to recommend products to a customer, you are able to view what recommendations were made by a person like a salesperson in real time in history. You get all the data. Now the first step for you needs to be prompt engineering, because the reason you want to focus more on prompt engineering is because you are using the foundation models. As and when the foundation models are tuned or upgraded or added more information with, your model upgrades itself, right? Of course, you need to change the name of the model. But then a model tuning means you are creating a replica of the big palm model and creating a smaller version of a model and training specifically on your data. Think about that. In the model tuning, which is on the right side, you are taking your data set, getting a copy or a scaled down version of a palm, for text or any other, or text is the only model that you can tune. So getting a scaled down version of text bison and training a model that is specific to your data. This, you are creating a smaller version of the model known as PETM, which is parameter, oops, PETM, which is parameter efficient tuned model. This model is residing in your Vertex AI, and you essentially created a copy of the model as an API call that you can access your tuned model, and you are responsible for management of this model going forward. So you may want to look at this PETM option as only when you have exhausted the prompt engineering options. I hope that makes sense. So let's look at the best practices of prompt design. And I would say one thing, that the prompt design is more of an art than a science. So zero shot, as I mentioned, I'm going to give you an example. What do you think is the most important problem facing the world today? So you have open question to this model, and it responds back. Don't read all of this, but it responds back with a climate change. So it gives you multiple information, but climate change is one of the most important problem facing the world today. Now you want to say, hey, I don't want to look at the climate change. So I'm just going to add a line, do not include climate change. Now, one thing then to remember is, because LLMs are processed or processing data or information or prompts in an open natural language, imagine a, a grade 3 or 5 fifth grader, how you're going to talk to him or her, provide as much detail as you could. So please note that the last line, do not include climate change, would trigger the model to look at other problems the world is facing. And this time it came back with the growing gap between the rich and the poor. Now, let's give an example of one shot. If I say, what do you think is the most important problem facing the world today? And global health is already there. So it's going to ignore global health, and it's going to look for another important problem. That is one shot. You provide an example and find it to find it something else. And few shots, you provide few examples. This is global health and climate change already. It's going to find the third one, poverty. So one shot, few shots, or one shot, few shots, and zero shot are different types of prompt tuning. And this is defined, and I'm going to share the slides with you. This defines the different parameters that you can modify: temperature, token limit, top K, and top P. Let's talk about tuning. Any questions? I'm going to take questions here. Please feel free to put in your questions in the chat. So tuning is a process wherein you are designing or making a model which is specific to your data. There are two examples that we discussed. Full fine tuning, that means you train from scratch, like you're hosting your own foundation model. And then you have PETM, which is parameter efficient tuning model, wherein you are creating a smaller model of the big text bison model, and you're creating a small layer on top of it with your data. This is one of those examples wherein the recommendations can be can be used. Again, I'm just giving an example. It could be any other use case that you're willing to provide. Now, let's look at a few prompt techniques that can be done on Google Cloud. Please put in your questions. More than happy to answer any questions that you might have. Now, Let's create a prompt. I'm going to create a code chat. This is the screen wherein you could see how a code chat works. That means you can put in your conversation like a chat. I'm going to say that generate a Python code for TensorFlow for image classification. And it's going to take a little bit of time, but it's going to come up with an answer. Now, if you look at it, this does an MNIST data set and it uses an optimizer, Adam. If you want to ask a question on this code, you can paste it again. Now this will hold context. Explain Adam optimizer, or why have you used Adam optimizer? What are the other optimizers that you can use? And also please note that it provides you the source from where it got the code. Very important. How do you understand from where this code is being brought in? And these are some sources that it referenced. If you look at it, explain Adam optimizer, here is how it has explained the Adam optimizer. So that is the code chat. You're asking the program to do, or asking this Cody to do a code for you and then asking a question on the code that it generates. This is one way of prompting. Next is, let me show you some other prompts. I have a demo on retirement planning. This was the question that Jignesh that you asked. How could I preset few things that this could ask? It says that you are a financial advisor providing financial advice. If you do not know, then please ask for an age, risk profile, and expected retirement age. It's a plain English that you have written. That means you need all of this in order to create a retirement advice. And then you ask a question or ask the prompt to create investment advice in stocks, bonds, CDs. So if you look at it, this is the context. You will ask for different things before you can create a profile. And then here is an example. So you provide an example on how you can create it. So this is an example for an age group of 40 to 45 years. And then there is another example of age group. Sorry, I'm scrolling a little faster. There was an age group of 25 to 30 years. So an age group of 45 or 40 to 45 versus 25 to 30 would be different. Now, let's start. Hi, what can you do for me? Create a table. Okay. Now, please recommend a financial plan for me. So it asks questions and it converses based on the context that you provide. It's going to ask me my age, risk profile, financial situation, and others. So I'm going to say I am debt free. Now, if you look at it, I did not code a prompt. I did not code a variable. I just said that ask for age and risk tolerance. So I'm going to say 36 and risk tolerance is medium. And it understands what's the age and tolerance. And then if you look at it, this is how it provides me some advice. So again, it's the context setting and the way you train the model based on users. I'll give you another example. Again, the same thing, right? If you remember, we asked for the categorization, define a category of the ticket. I could convert this into a free form. That means I don't want to provide a context or examples. And I can then say categorize the following. And I say, I have a question on my mortgage account being frozen. And if I try to generate it, it's gonna, without any examples, figure out where it is. So you can start with zero prompt, one shot, or multi-shot prompts. And then finally, if you want to tune the model, I can provide you, sorry, for model tuning on your dataset, follow this link. This provides you step-by-step detailed example on how you can tune a model specific for your data and specific for your task. So I'll do a quick recap before we take more questions. You want to start with prompt, zero shot, one shot, and multi-shot, and then you may want to focus on PTM. In most of the cases, because we all are engineers, we tend to tune the model, but I would say focus on prompt engineering first, followed by full model tuning or a PTM. So Katie and Heather, happy to take questions.
All right. So that was awesome. Thank you. I feel like I'm learning so much. I can't imagine the hackers. So one question, we only have one question so far. And of course, more questions will pop up in Dev Slack probably throughout the day. So we'll stay on top of those. If you're watching this asynchronously, feel free to ask those questions, even if you couldn't be here. But the one question is how to provide non-public data to these models.
So Jignesh, if you provide the non-public or any non-public data to these models, you are rest assured that your data is secured. So let me bring up a slide here that shows you how secured the model is. So sorry about that. I'm looking for a slide that I had that'll give you a better information. Sorry. Um, yeah, keep going if you have any other questions, because I'm just going to look for the slide that provides you a little bit of understanding. So Jignesh, this is how it is. Um, you are looking at an adapter model, or without even an adapter model, going to the large model, you are looking at your tenant, within your tenant, within your IAM, all the APIs and all the calls back to the PAM. And when it reaches to the PAM model, you are rest assured that Google does not use any of your data in flight or at rest at all for any other purposes other than responding back to you. So here it is. I think I shared this, and I can provide you the, whoops, sorry, and I can provide you the documentation where it mentions the same. It does not use any customer data or any parameters. And because you are coming in via the Google Cloud tenant, your data remains with you under your control all the time. Jignesh, I hope I answered your question.
So the other part of the question is beyond just the security portion of it, where and how do you feed data?
Good question. So you can feed an unstructured data like a doc or PDFs, put it on GCS, Google Cloud Storage. And from that GCS bucket, you can call this API. Now, there are two things that I wanted to put together. I mentioned you this particular, again, this is my Git. This is not a Google official Git. In here, I have listed down some use cases that you can use. In one of the use cases, I'm using PDF, and I'm using the Google Cloud Storage PDF. If you open this, It'll tell you how to use a cloud storage or a BigQuery for structured data, for example. And then all of these use cases are accompanying um, a YouTube video as well. So if you do not understand the code, this video, the YouTube videos that are listed here, explains you how this use case was achieved. I hope this answers your question.
I think that's great. And actually, Heather just sent me a question that's in Slack. So, can the Google team shed some light on the availability of any filters to minimize the risk of unwanted content like abusive, racist, profane content, which can be important for compliance reasons?
Absolutely. And probably I have missed it, or in fact, definitely I missed it, or I did not touch back on that. So, for example, if you open a prompt, there is something known as safety filter threshold. This safety feature threshold can help you block any violent, sexual, toxic, or derogatory content at all. So you can select block most, block some, or block few. If you say block most, it's going to be super diligent not to show you any content that is inappropriate or is out of context. I hope that answers the question. Again, this is the safety filter threshold, which is here. And then when you convert to the code, if you view code, you can add that parameter over here in the parameters section.
Awesome.
And I can provide you the details on how you can add that.
Yeah, if anyone wants like a more detail, more nitty gritty on that, obviously feel free to leave that in the comments on this video or over in Dev Slack. We'll be sure to kind of keep our eyes on all the portals so that everyone's questions get answered. Okay, is there anything else that you want to tell these hackers before we wrap up?
Yeah, so the best way, I mean, I have been part of multiple hackathons, and what I have understood is it may not be the code itself, but it has to be the idea that can help you win this hackathon. The code can be as simple as hello world. I'm just not, of course, hello world is not going to work, but I'm just giving an example. But code could be as simple as it could get. But where you're going to get a huge impact is solving a business problem, whether it's writing an email or classifying a ticket or recommending a product or think about other use cases that you might. So with that, thank you, Katie. Thank you, Heather. Jignesh, for asking good questions. Appreciate all of you.
Awesome. All right, thank you so much, and we'll see the rest of you in the next session. Have a good one.
Yeah, and Jignesh, you can reach out on Slack. I'm available in Slack as well, Jignesh.
Yes, we're all available in BigCommerce Slack. All right. No, till next time.
Thank you so much.